Okay, geometry class. We are starting our unit 9, last unit of the year, yay, on quadratics. I know that this here says, hold on, it says honors geometry, but it is the same for honors and regular right now. So this video works for both. Okay. So first of all, we need to identify the difference between these two words, equations versus expressions. And so really, it's quite simple. An equation has an equal sign in it. And when you have an equation, you're going to solve for the variable. You are going to tell me, what does x equal? Some number. That's your solution when you have an equation. Whereas with an expression, there is no equal sign. Therefore, you cannot solve for variable. You cannot say what x equals. All you do is simplify. And this is so basic and yet so important. You need to remember it. When you get a problem, the first thing you do is you say, okay, is it an equation or an expression? If it's an equation, I'm going to try to solve it. If it's an expression, I'm going to simplify it. Maybe factor it, maybe do different things to it, but you cannot suddenly tell me that x is 5 or x is 10 when it's an expression. So keep that in mind as we go through this. All right, so quadratic functions. Quadratic just simply means that the variable right here is being squared. There is a squared variable. And this a, this b, and this c are normally just numbers. So I could like say 6x squared plus 3x plus 2. So you can see that I have x here and x here. This x is being squared, and therefore it's a quadratic. If the highest degree is a 2, it's a quadratic. When I say a degree, that's the exponent. All right, so this has a degree, this term has a degree of 1 because there's an exponent of 1 there that we don't see. This term here has a degree of 2. And so when the highest degree of the equation or the expression, then it is a quadratic. It is a quadratic. Okay, so right here, let me erase some of this mess I made. Right here, get rid of you. So I have 2 erasing. Okay. So here is your general form. There's different forms to a quadratic. So here's your general form. And your general form, remember, f of x is the exact same thing as, well, not the exact same thing, but it is, in your understanding, the same thing as y. Okay? And so when you say f of x equals ax squared plus bx plus c, you could also say y equals. So over here I could write y equals for that quadratic. Notice that a quadratic at most will have 3 terms. If you have more than 3 terms, then you probably have some like terms you can combine. Okay, so in order to have the general form, the terms must be written in decreasing exponential powers of x. What that means is you can see the first term is the x squared term. The second term is the x to the first term. And then this technically also has an x. It would be x to the 0. And we know that x to the 0, or anything to the 0, is 1. And so then we don't need to write that. We can cross it out. But it's 2. So we have x to the second power, x to the first power, x to the 0 power. That is what it means by decreasing exponential powers. So when you give me the general form of a quadratic, make sure you start with the x squared, then x to the first, and then this is also called the constant because it doesn't change. No matter what x is, it's going to stay at 2. If I put 5 in for x, The value of this term changes, the value of this term changes, but the value of this term does not change. It will still be a 2. So it's called a constant. Okay. A is the leading coefficient. So hopefully you've heard the word coefficient before. The coefficient is the number in front of the variable. So the coefficient here is A, B is in front of the x to the first power, and C is the constant. It could be called a coefficient or it could be called a constant. Probably use constant more. But the A is the leading coefficient, which is A is the number in front of the x squared term. And this is very important. So this number determines which way the graph will open. So what we're going to be doing is graphing quadratics. And so a quadratic is going to either look like this, which is a parabola, or it's going to look like this, an open down. And so the leading coefficient, this number determines which way the graph will open. If A is greater than 0, then the graph opens up. If A is less than 0, then the graph opens down. So if A is positive, we open up. If A is negative, we open down. So even though I don't know anything about this equation of this graph, I know that the leading coefficient has to be negative because it's opening down. This graph, I don't know much about it. I don't know the equation or anything, but I know the leading coefficient has to be positive because it's opening up. Okay, vertex form. Here's another form of a quadratic. This is when it's factored a bit. And the handy thing about this form is that if it's in this form, then we know our vertex. And the vertex, over here on these graphs, the vertex is the turning point. Like here we're going up and then we come, well, generally you read a graph from left to right. So the graph is coming down and then it turns and goes up. The graph is going up, it turns and goes down. So the vertex is the turning point. And when you have an equation in this form, the vertex is HK. And so that makes it really easy to graph. If you know your vertex, then you're off to a great start. A is still the leading coefficient here in this form. And H, notice, is negative in the equation and would be positive here. So you got to be careful with that sign change. And K is just positive. K is easier to work with, but the H switches signs, so you be careful there. Okay. So all we're going to do this unit is we are not going to graph anything. We are simply going to analyze our equations of quadratics. So example 1, determine if the function is a quadratic. If so, what form is it in? What is the leading coefficient? And if it is in vertex form, what is the vertex? How will the graph open? All right. So we have a lot of little questions here, but they're not hard. We'll probably get through this pretty quick. So this first one. This is a quadratic because I see x is being squared. It is in standard form. By the way, we use, I wrote general form here. We can also use the word standard, and that is probably what I will say more. Standard form is the same as general form. Either one is fine. But anyhow, so this is in standard form. So I'm going to write that down because the first question is, well, determine if it is a quadratic. So yes, it is a quadratic. What form is it in? Standard. What is the leading coefficient? 3. Positive 3. The sign of that number is very important, so write it out for me. If it is in vertex form, what is the vertex? Doesn't matter here. And how will the graph open? Well, since the leading coefficient is positive, it will open up. All right? B. So the first question, is the function a quadratic? Well, when I look at this equation, I do not see an x squared term here. There's no x squared. No x squared term. Therefore, not quadratic. What is this? Well, you should be very familiar with that. The highest degree of this equation is x to the first power, therefore it is a line. We would call it a linear equation. And by the way, lines, linear equations also have a leading coefficient, LC 7. And LC is positive here, right? And so we know our line is going to go like that. A negative would go the other direction. Okay. C. So the first question is it a quadratic? Well, I look at this, and I know that if I would FOIL this out, remember what x minus 1 squared means? It means x minus 1 times x minus 1. You have to FOIL that, so you go x times x is x squared. X times negative 1 is negative x. Negative 1 times x is another negative x. Negative 1 times negative 1 is plus 1. You would clean that up, and you would get x squared minus 2x plus 1. And then you have this minus 3 here. So this would be x squared minus 2x minus 2. This is the standard form of this quadratic. These are the same things. And x minus 1 squared just means I'm FOILing that out. And so as soon as you see this x right here and this exponent right there, you know it is a quadratic. Next question, what form is it in? Well, this form right here is vertex form. So I'm going to write vertex form. What is the leading coefficient? Well, the leading coefficient would be this number right here. The number in front of the parentheses. If you look up in the notes here, the vertex or the leading coefficient is that A right there. So if there is no number there, like in problem C, then the leading coefficient is positive 1. All right. Next question, if it is in vertex form, what is the vertex? So the vertex is going to be, the negative didn't change, so that makes it a positive 1, and K is a negative 3. All right, and last question, how will it open? Well, since the leading coefficient is positive, it's going to open up. Next one, D. Again, is it a quadratic? Well, I see an x here inside the parentheses, and it's going to be squared. Therefore, I know it's a quadratic. What form is it in? That is vertex form. What is the leading coefficient? I look here, and I see a negative with no number. So that means the leading coefficient is negative 1. If it's in vertex form, what is the vertex? Well, the vertex would be, okay, so here, remember your standard form, I'm getting sick of this color. Let's see. Okay, your standard form is A times x minus h squared plus k. So right here, I switched from a minus sign to a plus sign. Therefore, that 4 had to be a negative. And then k is this lovely fraction, negative 2/3. Finally, how will it open? Right there, this sign and my leading coefficient tells me it will open down. E. Yellow's not making me happy either. Ooh, I like that color. Okay. All right. Is it a quadratic? Well, there's my x and it's being squared. So yes, it's a quadratic. What form is it in? Well, this is in standard or general form. Remember, standard form is ax squared plus bx plus c. So this equation is in this form, but the difference, like for example, a is a negative 1, c is a 1. What's b going to be? In this equation, b equals 0, because there is no x to the first power in this equation, but it is still a quadratic and is still in standard form, but b has to be 0, because if b is 0, it takes out that equation. So we're in standard form. What's the next question? Oh, what's your leading coefficient? Negative 1, right there. We don't have a vertex. So all we have to say now is how is it going to open? Well, because this is negative, it's going to open down. Next one, we are in standard form. Well, first of all, it is a quadratic because of this x squared. So it's a quadratic. It's in standard form. Leading coefficient is 1/2, positive 1/2. And because the leading coefficient is positive, it will open up. If you think you got this, go ahead and pause the video and finish these on your own, and then come back and check with me with my answers. All right, G, there is no x squared in that equation. There's two different x's, but neither is squared. In fact, we should combine those, right? Those are like terms. It would be 4x plus 2. And so we would say it is not a quadratic. It's actually linear. H, this equation is a quadratic. It would need to be rewritten. This whole term should be first because that's my x squared. So I would write 3 times x minus 2 squared plus 7. So it is a quadratic. It's in vertex form. The leading coefficient is positive 3. Notice here, this is not the leading coefficient because it's not in the proper order. Make sure it's in the proper order before you tell me the leading coefficient. It's going to open up because leading coefficient is positive. And then the vertex, so the negative didn't change for the h, so I put a 2 there. And the k is a positive 7. And there's my vertex. Next one. This, again, is a quadratic because x is going to be squared. It is in vertex form. Let's see, the leading coefficient is positive 7. It will open up because it is a positive there. And finally, what is the vertex? Well, this is my h value and the sign change. So this has to be a negative 1. And what's k out here? Remember, k would be right there. 0. There is no k, so it's 0. All right. Finally, j. First of all, go ahead and rewrite that because you always want to have your decreasing powers. So the x squared term has to come first, so it's negative 2x squared. Please remember the sign in front of the number goes with it. So this is a negative 2. This is a positive 7x plus 1. And so this is in standard form. So it's a quadratic. It's in standard form. The leading coefficient is a negative 2. It's going to open down. And there you go. All right. Oh. I was wrong. I'm sorry. I thought we weren't graphing, but here we are graphing. All right. Well, we're just talking really about the graph. So here we go. The graph of a quadratic function is a parabola. You have to know this word, and you will, because we will use it all the time. And this green line over here is your parabola. This parabola is like the basic parabola. Of course, our graphs will not always look like that. But anyhow, the parabola is the graph of a quadratic. There are 3 possibilities for the roots. Now let me explain that word for you. These words basically mean the same thing. X-intercepts, remember this is your x-axis, this is your y-axis. X-intercept is where does the graph intercept the x-axis. Another word for this is the root, or the 0, or the solutions. And when you're talking about quadratics, these refer basically to the same thing. So, let me show you on this little chart. You have 3 options for a parabola. So one option is you could have 2 roots or 2 solutions. That would be something like this. If I had my graph, and let's say this is my parabola, We'll put it over here to the side. It's opening up. And look at it, crosses my x-axis 2 times. So that means I have 2 solutions, or 2 roots, or 2 x-intercepts. It intercepts 2 times. Or the other word is 2 zeros. It crosses 2 times. We also know about this equation that the leading coefficient is positive, right? Because it's opening up. All right, another option for any parabola is that it has 1 root. That means that it has to touch my x-axis but not cross it, which means, let's put this parabola on there right there. That means the vertex is on the x-axis. So that could go down, it could go up like this. Vertex is on the x-axis. All right, so we have 1 solution, 1 x-intercept, 1 zero. Vertex is on x-axis. All right, which means for your vertex, this number has to be 0, right? It's not, the y number is 0. Okay, last option, here's your graph. We could have a parabola like up here. It opens up, so the leading coefficient is positive, but the vertex is above the x-axis, so there is no solution. There is no x-intercept. It never touches the x-axis. There's no 0. There's no root. Vertex. Well, I don't want to say that, because you could also have this one. You could also be floating down below, correct? So those are your only 3 options. Every time you solve a quadratic, you will either have 2 answers, 1 answer, or no answers. Okay. So the vertex, as we talked about, is the turning point. And so we have this word maximum or minimum. So on this graph right here, here's my vertex. I would say that vertex is a minimum because every other point is above it. This is the lowest point on the graph. So this vertex is a minimum. Okay? This vertex is also a minimum. Every other point on the graph is above it. But this vertex is a maximum because every other point on the graph is below it. This vertex is a minimum, and this vertex is a maximum. And so the vertex is either the max or the min of the graph. Okay? And remember, if the leading coefficient is positive, it's opening up. If the leading coefficient is negative, it's opening down. And then finally, there's an axis of symmetry, which you can't really see on my parabolas because they're kind of messy. But if we go up here to this parabola, an axis of symmetry is a line that the graph reflects over. And so in this case, the axis of symmetry is actually your y-axis right down there. And the cool thing about a parabola, like here's your vertex. Your vertex is always on the axis of symmetry. And then this point here is the same distance as here from the axis of symmetry. So it's a reflection. This point reflects to here. Same distance. Equal, equal, equal. And so really, parabolas are very easy to graph. If you know your axis of symmetry and you know your vertex point, you just need to find 2 points and then you just flip them across the axis of symmetry. Notice you don't flip them across the y-axis. This time we're only doing it because the y-axis is the axis of symmetry. But if I had this graph, let me try to make a good one. Oh, I have some examples here. These notes are different than the ones I'm going off of. But anyhow, okay, so we'll just go on. Example 2. Well, wait a minute. Axis of symmetry. The axis of symmetry is a vertical line, it is always the y coordinate of the vertex. And so you would write your equation as y equals -4, like in this case, y equals -4. And it is always halfway between two roots. Now remember, roots are also what the solutions or the x-intercepts. All right, so let's look here and see if there's more on these notes. Okay, so for each graph, give the vertex, the axis of symmetry, the number of roots, and if the vertex is a max or min. All right, so this is a parabola here. The vertex is the turning point, and so my vertex would be right here, -2, 1. So the axis of symmetry then has to be the line. It's a vertical line that goes through the vertex. There's my axis of symmetry. What's the equation of that axis of symmetry? Hold on a minute. All right, sorry, I was just realizing that I misspoke earlier, so let me go back to this. I told you that the axis of symmetry is always the y-coordinate. I'm wrong. It's always the x-coordinate of the vertex. The vertex or max, this is always the y-coordinate. Okay, so down here when it says what is the axis of symmetry, we need to know the equation of this dashed line right here, which would be x equals the x-coordinate -2. That's my axis of symmetry. So my AOS is x equals -2. That's an equation, so you got to tell me the equation. You can't just tell me a number, -2. You have to tell me an equation, and this is the line, x equals -2. The number of roots, well, here's a root, and here's a root. There's 2 roots. And if the vertex is a max or a minimum, this vertex right here is the highest point, and so it's a maximum. And what is the maximum? The max is always the y value of the vertex, so the maximum is +1, the y value. So axis of symmetry is the x value of the vertex, the max or min is the y value of the vertex. And now I want to talk about this right here. It's always halfway between the 2 roots. And so here's a root. If I didn't know this vertex, let's say we didn't know what that was. All right. Well, if this is -3, 0 and this is -1, 0, I know that the vertex has to be at -2. It has to be halfway because this distance has to equal that distance. And I also know that, okay, here, this goes over here, and that is 2 over, so I know I have to go 2 over, and there's another point right there. This distance has to equal that distance. Okay, last one. For each graph, give the vertex. So the vertex here is the turning point for -4. Oh, let's see. The axis of symmetry, remember, goes through the vertex. It's a vertical line through the vertex. So I know this is my axis of symmetry coming down through my vertex. So my axis of symmetry is the equation. It's a vertical line, so I write x equals my x value of my vertex, which is 4. That's my axis of symmetry, an equation. Next, the number of roots, 1, 2. There's 2 roots. And if the vertex is a max or a minimum, this time it is the lowest point on the graph, so it's a minimum. And what is the minimum? My y value of my vertex, which is -4. There we go. I think that's it.